Class.
Yes.
Denny. Good job, thank you. All right, okay, consider the differential equation. So we did this one actually a couple weeks ago on how to find the slopes. So on the axis provided, sketch slope field for the given differential equation at the 6 points indicated. So we have 6 points here. So this is going to be 0x, 2 for the y. 0x, 2 for the y. So that would be, so 2 squared, 0 minus 1. That's going to give me a -4, right? So the slope is -4. Next one. So it is going to be 0 for the x and 1 for the y. My slope is -1.
Okay.
And next one. So 0x, 0 for y,
0.
0. So that slope is 0.
Oh.
Okay, right here at 1. So what's going to happen special at 1? When x is 1?
Undefined.
Undefined. 0 on the bottom, right? 1 minus 1 is 0. That's undefined, right? So this does not exist. That whole line does not exist.
Oh, so you don't.
So there's no lines there.
Okay.
No lines there. That's undefined. Okay? So what if we plug in 2, 0 right here? What do you think the slope is?
2. Wait, hold up. 2, 0. Oh, okay. Hold on. -4.
Try again. What's 0 squared?
Oh.
Okay, so this slope is 0. Okay, next one up is going to be 2, 1. So that's going to be positive 1. Yeah, 2 minus 1. Yeah, so it's going to be positive 1. So that means that this goes like that. My last one is going to be that one over there, so it's going to be 2 squared over 2 minus 1. That's going to give me a positive 4. There we go. Okay. So, and positive 4 goes up more, like that. There we go. Was that so bad?
No.
No. Just forgot to do it, or how to do it, or...
I forgot to add.
Hey, okay.
Bro.
It's not as bad. Like, we,
No.
little bit at a time, if you just look at it and consider what we already know, and, you know, just basic things. So, all right, next part. Let fx be the particular solution to the given differential equation with the initial condition of f of 2 is equal to 3. That means that if I have an initial condition, that's going to tell me what my c is. If I have a particular solution, you know when you take your integration, you get plus c. This point right here is going to tell me I'm going to have a particular solution for this. It's going to give me a c value with this. Write an equation of line for the tangent to the graph of this at x equals 2. So, and use your equation to approximate f of 2.1. So, it said a lot of things. So, I have right?
Yes.
Okay, so now to get a solution for this, I need to separate my variables. So I have a dy and I have a dx. So I'm going to have my dy's on the left and my dx's on the right. So
Okay.
watch this. Multiply both sides by dx. Multiply by dx. I'm going to change colors. Why not? Right?
Okay.
Okay, so that's going to cancel out that dx. And now I have a dy over here. Can you turn off the music, please? I don't even know how you could actually concentrate on anything. That's probably why you're like totally lost, because, yeah, only got that rattling around in your brain. Okay, so y squared. So I need to get that over here. What would I do to it on the right-hand side to get rid of it over here? Yeah, I'm going to divide both sides by y squared. So this over here is now going to turn into 1 over y squared, and those are going to cancel. So now I have 1 over y squared dy is equal to 1 over x minus 1 dx. What does this look like now? What do you think I should do to get rid of my dy and my dx? Can I take integration of both sides? Look, it's already set up. Looks like it. By separating those out, I now could actually get rid of this, because when I take the integration, the dy goes away, right? I take the integration, the dx goes away, right? So I'm going to rewrite it a little bit. So this is going to be y negative 2 I'll leave this here. So when I take the integration of this one, it's going to give me a negative 1 over, remember, what do I do to my exponent?
Add 1.
I add 1, right? So that's going to become negative 1, right? So negative, so it's y to negative 1. Not negative 1, but it's already down there. So it's just y to the first. Because I already moved it to the bottom. Equals. Can anyone tell me what that one is right there? Yes, very good, natural log. So it's going to be, and because this is important, okay, that x minus 1, what must I include there?
Absolute value.
Very good. So absolute value of x minus 1, and then I get my plus c. Remember, we only have 1 plus c. We technically should have one on the left and one on the right, but then mathematically, it's just one constant that I added them both together. Now, I'm going to use that, and I'm going to use my point. My point they give me was x equals 2, and y is 3. So, I'm going to change up colors, because I'm on a different part here. So that's going to be 1 over negative 3 equals ln of 2 minus 1 plus c. All right, 2 minus 1 is going to give me,
1.
what's the ln of 1?
0.
0, very good, so 0. 0 plus c, so negative 1/3 is equal to c. Now I have a particular solution. So now I'm going to put that back in, and so that's going to turn into negative 1 over y equals ln absolute value of x minus 1 minus 1 over 3. So part of this one right here says write equation for the tangent line, so I want to turn it into y equals. So I could do it from here, but I want it as a y equals to make my life a whole lot easier. So what would I do to both sides to get the y out of the denominator? Can I multiply both sides by that?
Yeah.
Yeah, and it'll cancel it over here on the left, but it'll leave me the y on the right. So now I'm going to have a y over here. So it's going to be a y times all this, right? Right?
Yes.
But then I'm multiplying by all this. What do I do to get rid of all this?
Divide by.
Divide. So now I can have divide both sides, so it's -1 over here, which is this. So I'm dividing by all that.
Yeah.
Okay. Now I'm supposed to approximate something. 2.1, right?
Yeah.
2.1. So let's see. So now that I have that set up, I'm gonna like plug that in. Let's change our colors again, cause why not? Oh.
Is there perfume?
No, I'm still hurting from yesterday's attack.
No.
So yesterday there was.
Let's see.
All right. Ugh. Oh, I missed something. No, before I do this one, I can't do this one yet because I still don't have the slope. I have the equation, but I don't have the slope. It says right here, for the particular solution, we got the y equals, but now I need to find out what the slope is. Let's find the slope at the point 2, 3. So that's going to be 3 squared over 2 minus 1, which is just going to give me 9. So I have my slope now. Now I could actually plug it in. So my tangent line is going to be from here. So, do we know what my y is? It was a 3, right?
3.
Okay. So y minus 3 equals 9 quantity x minus 2.
Okay.
Now I get y equals 9 quantity x minus 2 plus 3. And now we're going to do the last one because I didn't plug it in with the slope. So now my last one, which is my 2.1,
Yeah, 2.1.
there he goes, equals 9 quantity 0.1 minus 2 plus 3. So that's going to give me just 0.1 times 9. So 0.1 times 9, that's going to be 0.9 plus 3. So 3.9 is my value for f of 2.1. So we found the slope, we found a point, using point slope, and then use that, whatever number they give me, I could actually plug that into this right here to try and approximate what it is. Because they're going to have a bunch of these on the test. Every year they actually have a bunch of the questions like this. So plug in, get your slope, plug in your point, and then from there you could actually just plug in, because these are non-calculator parts. And that's the reason why they try to make the math a little bit easier. So come on, 9 times 0.1 plus 3. So yeah, non-calculator parts. And was that the last part?
No, there's like a C. Unless we already found the C and then it's just like.
Hold on, let me see. Find the particular. Oh! I did them out of order.
Oh.
So my particular solution is here. So this is actually my, this one right here is part C.
That right here.
This one right here is my part B. And
Part C is like the y equals
and part A, this is all part A. My bad, I'm sorry, I did it out of order.
What was the other thing then?
So right here, particular solution,
We got the answer 3.9. That was
3.9. That one goes with this. Use your equation to approximate.
Oh, okay.
So that's part of B. Because I did C first, and that's what this was.
If you did B, wouldn't you have to do C anyways?
Do what?
If you did B, wouldn't you have to do C anyways?
No, because they're different. Because if you look from part B, what did I do? I went up here, I plugged in my point, I got the slope, right? So yes,
Yeah.
because it says, particularly given the equation with the initial condition exists, write an equation for the tangent line. Isn't this dy dx?
That's dy dx.
Yeah, that's the slope of the tangent line, right?
Yeah.
That's the equation for the slope of the tangent line. So I plug in there, and then I approximate. So the particular solution part right here is where you actually have to do this. All my differential equations right here. So doing my integration part.
Okay.
So I did it out of order. I am sorry. I apologize.
I'm gonna try and not get confused.
I know. I'll kill myself later for this.
Crazy.
Okay. All right. I will leave you guys alone. You guys got about what, 10 minutes? So like, share, and subscribe.